With an elastic limit, the displacement produced in the spring is directly proportional to the force applied. Means how much we force apply produce displacement in the spring. Force directly proportional to displacement. F is equal to kx. K is the spring constant or stiffness. F is the force applied and x is the displacement or extension. Hooke's law is applicable to all kind of deformations on all type of matter that is solid, liquid or gases within a certain limit. Beyond this limit, the springs deform permanently. Hooke's law is based on the concept of elasticity. Let's discuss it. With an elastic limit, the displacement produced in the spring is directly proportional to the force applied. Means how much we force apply produce displacement in the spring. Force directly proportional to displacement. F is equal to kx. K is the spring constant or stiffness. F is the force applied and x is the displacement or extension. Hooke's law is applicable to all kind of deformations on all type of matter that is solid, liquid or gases within a certain limit. Beyond this limit, the springs deform permanently. Hooke's law is based on the concept of elasticity. Let's discuss it. With an elastic limit, the displacement produced in the spring is directly proportional to the force applied. Means how much we force apply produce displacement in the spring. Force directly proportional to displacement. F is equal to kx. K is the spring constant or stiffness. F is the force applied and x is the displacement or extension. Hooke's law is applicable to all kind of deformations on all type of matter that is solid, liquid or gases within a certain limit. Beyond this limit, the springs deform permanently. What is elasticity? It is a property of a body to regain its original shape and size when deformed. What is elasticity? It is a property of a body to regain its original shape and size when deformed. What is elasticity? It is a We can define force as a push or pull that changes or tends to change the state of rest or motion of an object or changes the direction or shape of an object. It is possible to change the shape or size of a solid by applying force. A sufficiently large force will deform or break an object. States of equilibrium. Stable equilibrium. A body is in stable equilibrium if it is slightly displaced and then released, it returns to its original position. For example, suppose a box lying on table in equilibrium, tilt the box slightly about its one edge on releasing, it returns back to its original position. A body is in a stable equilibrium when it meets the following condition. Number one is center of gravity at its lowest point. Nature always preferred lowest energy state, so object is in most comfortable there. Number two condition is when object is tilted, center of gravity rises. Because object gains potential energy, so the center of gravity rises. Number three condition is object return back to its original position because center of gravity has risen. The weight of object creates a restoring force. This force pulls the object back to its original position. The center of gravity lowers again. That's why body return to stable equilibrium. Unstable equilibrium. A body is in unstable equilibrium if it does not regain its position after being displaced. For example, a paper cone. Take a paper cone and keep it in vertical position on its vertex. It topples down on releasing. A body is in unstable equilibrium when it meets the following condition. Its center of gravity is at highest point. When it is tilted, its center of gravity is lowered. Its previous position cannot be restored. Neutral equilibrium. A body when displaced from original position remain in equilibrium in new position is in neutral equilibrium. Consider a ball placed on horizontal surface in equilibrium. When it is displaced from previous position, it remains in equilibrium in new position. This is neutral equilibrium. Terminal velocity. It is the maximum constant speed that a falling object reaches when the downward force of gravity become equal to the upward force of air resistance. Let's understand it. When object start falling, Gravity pulls downward, speed increases, air resistance is small, so object accelerates. As speed increases, air resistance increases, it pushes upward, gravity stays the same, acceleration becomes smaller. At terminal velocity, gravity is equal to air resistance, net force becomes zero, acceleration becomes zero, speeds become constant. This constant speed is called terminal velocity. Let's talk about the conditions of equilibrium. A body must satisfy certain conditions to be in equilibrium. First condition of equilibrium is that sum of all the forces acting on a body must be zero. Like a basket of apples on the table, paratroopers moving down with terminal velocity also satisfy first condition. Second condition of equilibrium is that sum of all the clockwise and anti-clockwise torques acting on a body is zero. A body can satisfy first condition of equilibrium and still does not obey second condition of equilibrium. If you want to know what is terminal velocity, comment down below. What is equilibrium? When a body does not possess any linear or angular acceleration, it is in equilibrium. For example, a book lying on a table at rest, a chair lift hanging on supporting ropes. Let's discuss the types of equilibrium. Number one is static equilibrium. A body at rest is said to be in static equilibrium, like a wall hanging, a building, or a bridge. Number two, dynamic equilibrium. A body moving in that does not possess any acceleration, neither linear nor angular, is in dynamic equilibrium. Let's understand it in an easy way. There are three conditions of dynamic equilibrium. Moving object, it means an object that is already in motion. Number second condition is no linear acceleration, means no change in speed or direction. No angular acceleration means body rotating at a constant speed, not speeding up or not slowing down. Example, uniform downward motion of steel ball through viscous liquid or jumping of paratroops from helicopter. What is couple? Two unlike parallel forces of same magnitude but not acting along the same line forms a couple. We can take the example of forces required to turn the steering wheel of a car. The two equal and opposite forces balance, so the wheel will not move up, down, or sideways. However, wheel is not in equilibrium. Center of mass of a body is a point where the entire mass is considered to be concentrated. Motion of an object can be studied by tracking its center of mass. Center of gravity. Center of gravity is the point where the weight of the body acts. On Earth, center of mass and center of gravity are usually the same. Principle of movement. The principle of movement states that for a body in equilibrium, sum of clockwise movements is equal to sum of anti-clockwise movements. If movements are balanced, the body does not rotate. Example, seesaw balance with children on both sides. What is turning effect of force in daily life? The turning effect is the ability of a force to rotate an object around a fixed point. The greater the distance from the fixed point, the greater the turning effect could be. Examples are opening the door or using spanner or bottle openers. Moment of force or torque. Moment of force is the turning effect of a force about a pivot or a fixed point. Its formula is moment is equal to force into perpendicular distance. A force causes rotation when applied away from the pivot. Example, pushing a door near the handle is easier than pushing near the hinges. Ever pulled something and felt the force go in two directions at once? That's not magic, that's physics. When a force acts at an angle, physics break it into two parts called resolution of force. One part acts horizontally, the other vertically. These two parts are perpendicular and they make problem easy to solve. Imagine pulling a box with a rope at an angle. One component pulls the box forward, the other lifts it slightly upward. Same force, two effects. Now here is the reverse idea. The resultant force is one single force that replaces these components. We find its magnitudes using Pythagoras theorem and its direction using trigonometry. This tells us how strong the force is and where it acts. Physics becomes easy when you break forces smartly. For more simple physics, the head-to-tail rule of vector addition is a graphical method where you draw vectors, placing the tail of new vector at the head of the previous one. The resultant vector is drawn from the tail of very first vector to the head of very last vector, showing the net effect. It is used in physics to add forces, velocity, and displacement vectors. Unlike parallel forces are forces that act parallel to each other but in opposite directions. When these forces oppose each other, the stronger force decides the direction of motion. Example, one person pushes a box forward while another pushes it backward. Like parallel forces are the forces that act parallel to each other and in the same direction. When forces act in the same direction, they support each other and add up to produce a stronger effect. For instance, two people pushing the car forward from behind. Both forces act in the same direction, so the car moves more easily. What is centrifugal force? Centrifugal force is the outward force that appears to act on an object moving in a circular path. It is not a real force, it is a felt force due to object's inertia. Let's understand it in easy words. When you sit in a car taking a sharp turn, you feel pushed outward, means towards the door. This is not a real force, it is just your body wanting to continue motion in a straight line. Or in simple words, inertia. Is the real force that pulls the body inwards, whereas centrifugal force is the apparent force that is felt outward. Example of centrifugal force is water being thrown outward when a bucket is swung in a circle is due to inertia, not a real force, outward force. Centripetal force. Centripetal force is a force that keeps an object moving in a circular path. It always acts towards the center of the circle. Formula is F is equal to mv square upon r. Let's understand it in an easy words. When something goes around in a circle, it always wants to fly outward due to inertia, but centripetal force pull it inward, keeping it on the curved path. Example of centripetal force is the tension in a straight line. You swing a ball in a circle. Gravity keeps planet in orbit around the sun. Friction keeps a car on a curved road. Friction keeps, according to the law of conservation of momentum, the total momentum of a system before collision is equal to the total momentum of a system after collision when there is no external force acting on a system. Mathematically, it can be written as m1, that is mass initial mass, or u1 is equal to initial velocity, plus m2 u2 is equal to m1 v1 plus m2 v2. m1 is the initial mass, u1 is the initial velocity, m2 is the final mass, and v2 is the final velocity. This law means momentum cannot be created or destroyed. During a collision, objects may change speed, but the total momentum of all objects stays the same. Example, two ice skaters push each other, one moves left, the other moves right. Both move in opposite direction, but the total momentum remains the same as before pushing. What is momentum? Momentum is the quantity of motion of a moving object. It depends on how heavy the object and how fast it is moving. Formula of momentum is P is equal to mv. P is the momentum, m is mass in kilogram, v is velocity. Its SI unit is kilogram meter per second. Let's understand it in an easy way. A light object moving fast can have momentum. A heavy object moving slow can also have momentum, but a heavy object moving fast has very large momentum. Let's understand it with an example. A truck at slow speed has more momentum than a fast moving soccer ball because the truck has much larger mass. Types of motion. Objects can move in different ways depending on the path they follow. Number one is translatory motion. When an object moves from one place to another, every point of the object moves the same distance in the same direction. Number one type of translatory motion is linear motion. Motion in a straight line. Example, a car moving on a straight road or a ball rolling on the floor. Circular motion. Motion in a circular path around a fixed point is circular motion, like the motion of a fan blade or earth revolving around the sun. Now, random motion is motion with no fixed path or direction is random motion, like the movement of dust particles in air or gas molecules in a container. Number two type of motion is rotatory motion. When an object spins about its own axis, that is rotatory motion. Example, spinning of a top or earth rotating on its axis. Number three is vibratory motion. When an object moves back and forth about a fixed position, it is vibratory motion, like uh, motion of a simple pendulum or motion of a guitar string. What is rest? An object is at rest if its position does not change with respect to the reference point, and an object is in motion if its position changes with respect to the reference point. Imagine you are sitting in a bus. You are at rest with respect to the bus seat because your position does not change relative to them. But you are in motion with respect to the road or trees outside because your position changes relative to them. So rest and motions are relative terms. They depends on the reference point. Why does a big iron ship float while a small iron nail sinks? The ship is hollow and displaces a lot of water, producing a large upward force. The nail displaces less water and gets a smaller upward force. That's why it sinks. Why do we feel lighter in water? Because water pushes upward with a buoyant force, reducing the effect of our weight. Why does oil float on water? Oil has a lower density than water, so water pushes it up with greater force. Measuring volumes of irregular objects. Archimedes discovered this principle while finding out whether a crown was made of pure gold. If you put a stone in water, the water level rises. This increase in water level is equal to volume of stone displaced. Formula of buoyant force is weight of the object is equal to weight of the object displaced. F is equal to rho, that is density, volume, V, that is volume displaced, and G is the gravity. Let's discuss some real life examples of Archimedes' principle. Number one is boat floats. Boats are made hollow so they displace a large amount of water. This increases the buoyant force and makes the boat float. Number two is helium balloons rise. Air is also fluid. A helium balloon rises because here helium displaces heavier air, so air pushes it upward. Number three is swimming. When you try to push your hand into water, you feel the water pushing back. This is buoyant force. Why do objects float or sink? Number one, object float if the buoyant force is greater than weight of the object. What is buoyant force? In simple word, you can say the force applied by the water on the object is the buoyant force. If the buoyant force is greater than weight of the object, then obviously the object will float on the water. Example, a piece of wood float because the water pushes more than its weight pushes it down. Number two condition is object sink. If the buoyant force is less than weight of the object sink. Means if the force applied by water is less than the weight of the object, then obviously the object will sink in the water. A stone sink because its weight is greater than the upward push of water. Number three condition is object stays suspended. If the buoyant force is equal to weight of the object does not rise or fall, but it stays in the middle of the water obviously. Example, a fish can stay at one depth by adjusting its bladders. Archimedes principle. When an object is fully or partially immersed in a fluid like liquid or gas, it experiences an upward force called upthrust or buoyant force equal to the by the object. What does it mean in simple word? When you put something in water, the object pushes water out of the way. This is displaced water. Water pushes back with an upward force. This upward force is called buoyant force. And the amount of water upward force is equal to weight of the water that the object pushed away. If we have to find the density of a solid shape that is irregular, we are using the following step. Use a measuring cylinder with water. Note a scientific notation. How we can determine the density of solid? Density is the amount of mass in a unit volume of a substance. Its formula is rho is equal to m, where rho is representing density, m is representing mass in kilogram, volume, v is volume in m cube. SI unit is kilogram per meter cube. Objects with high density have more mass packed into a small space, like iron. Objects with low density have less mass for same volume, like wood. prefixes, and symbols for unit to express value.